Welcome to Brain Vision.
Okay, so we can apply the energy balance equation in this question. So we know E dot in is equal to E dot out. If we expand it, we have W dot F plus W dot in, and then plus M dot H1 is equal to M dot H2 plus Q dot out. W dot F here is the power input from the fan, and W dot in here is the power rating of the electric resistant heating elements we are looking for to determine. And the M dot here is the mass flow rates of the air, okay? And H1 here is the initial enthalpy for the air, and the H2 here is the final enthalpy for the air. And we know Q dot out is the rate of heat loss from the air, okay? So if we do some arrangement here, we'll have W dot in is equal to M dot times H2 minus H1 plus Q dot out minus W dot F. So we know H2 minus H1 can be equal to Cp times T2 minus T1, which is Cp times delta T. Cp is the specific heat of the air, and the delta T is the changing temperature. So eventually you have W dot in is equal to M dot Cp delta T plus Q dot out minus W dot F. So we know the mass flow rate is 0.6 kilogram per second. And we know Cp, which is the specific heat of the air, is 1.005 kilojoule per kilogram times degrees Celsius. Only we know the changing temperature is 7 degrees Celsius. We know Q dot out, which is the rate of heat loss, is 300 watts, which is 0.3 kilowatts. And the power input from a fan is also 300 watts, which is 0.3 kilowatts. So now let's plug in back to the equation to determine the power rating of the electric resistance heating elements, which is equal to 0.6 kilogram per second, and then times Cp delta T, which is 1.005 kilojoule per kilogram times degrees Celsius, and then times 7 degrees Celsius, and then plus 0.3 kilowatts minus 0.3 kilowatts, and this will give us the power rating of the electric resistance heating elements is about 4.22 kilowatts. And this is the answer for this question.